Okay, so for today, we will be discussing about MOS. Okay, MOS or methods of successive substitution. Okay, so for example, our problem is x cubed minus 3x plus 1. Okay, so to find the value of x, which will transform this equation into 0, we will convert this equation into a form where x is unknown. So for example, to get x, say x cubed minus 3x plus 1 equals 0. So we wanted to transform the equation into x. So that becomes x cubed plus 1 equals 3x. After transposing negative 3x. And then divide both sides by 3. So we got x equals x cubed plus 1 all over 3. So this is our running equation to get the x. Okay. Okay. So after setting up this equation, uh, so we wrote down this equation into xi plus 1 is equal to xi cubed plus 1 all over 3. So we will start with the starting value of xi, say 0.5, and then use that to compute xi plus 1 according to this equation. Okay, so which is 0.5 cubed plus 1 all over 3 is 0.375. And then find out the relative error. So our final value, 0.375 minus the initial value, 0.5, all over the final value, 0.375, we get a relative error of 33.33%. Okay, then we do that successively. Okay, so for the next iteration, our xi now is this one. Okay, and then find out the xi plus 1 after substituting this equation until you got the relative error of within a tolerable value, say less than 10% or 5%. Okay, so let's come up with a spreadsheet iteration for this. Okay, so where's the spreadsheet? Okay, so let's set up the equation, which is snapshot this. X cubed minus 3x plus 1 so I'll put in xi and then xi plus 1. Find the relative error. Okay, so our xi is 0.5, the initial, and then our xi plus 1 is according to this equation. There, so equals xi cubed plus 1 all over 3. Edit the formula. I think this is already good. There. Then find the relative error. this minus this all over the final. So I got 0.33. So for our next iteration, so this is iteration 1, iteration 2, so equals 1 plus this. Then say I'll drop down this. So our next iteration will be this one, xi plus 1. So I'll just drag the formula and this one, and also drag this. So see, as you notice, from iteration 4 until say 12, we're coming up with the same xi and xi plus 1. So that means we already reached the solution such that the relative error is negligible. Okay, that means the value of x is 0.347. Say this one. Okay, if we plot this equation, this is x, this is y. Okay, say if x is 0.5 equals x cubed minus 3x plus 1. There. Then say I'm using this plus 0.1 increment. Okay. Okay, that's it. Point 6. 0.347. So I'll use negative 0.1 instead. There. So as you see, there's a change in sign over here. So I'll try to use 0.01. Okay. See, so there's the change of sign here. So let's plot that. Insert chart. Select data. So our x is this. And then our y is this. Enter. Then OK. So at this vicinity of x from 0.2 to 0.5, the graph of x cubed minus 3x plus 1 touches the x-axis in between 0.3 and 0.4, which is exactly, say, about 0.347 according to our numerical methods approach using method of successive substitution. Okay, so this is the graph of x cubed minus 3x plus 1. Take note, we were only able to get a single root of this equation because 0.347. What if we wanted to find out, or say get the picture of this equation, not only on this vicinity of x from 0.3 to 0.4. So I'll assume another x value. Okay. So say I'll copy this, make another graph here, say 1. What is this value? So say 0.2, say plus. Here we don't see a lot of change in sign, only here. That means this equation touches the x-axis again from 1.4 to 1.6. So that's another solution for x. Okay. So the region between 1.4 to 1.6. So insert, which is this one. So from okay, let's change this. That's our x. Okay. (1.2 to 1.6). So I'll make this 0.1 only. So we can magnify the solution. Right. So there's another root here. Okay, so after getting our x from method of successive substitution, which is 0.347, because our relative error is within the tolerable value that we set. If you look at the actual graph of the function x cubed minus 3x plus 1, so this is the graph of that, you will observe that the equation touches the x-axis at about 3 times. So what we got earlier is this, 0.347. So how about the other two roots? Okay. That's a problem with the method of successive substitution. We were not able to get the other 2 roots. Okay. We were only able to get the 0.347 root, which is here. So what I'll be going to do is I'm using the Newton's method to get the other 2 roots. Okay. So the setup is here. So this is Newton's method. So remember, for the Newton's method, we set up xi, the f of xi, of course the derivative, because Newton's method uses the slope, and then the formula for xi plus 1, which we discussed last time, and then of course another column for the relative error. Okay, so for the other 2 roots, we will be using Newton's method. So x cubed minus 3x plus 1, xi plus 1, as discussed before for the formula of xi plus 1. Okay, so let's say for the next root, again we got this 0.34 something here. So I'll assume our initial x is around 1 and 2, right? As you see here, it's between 1 and 2. So for here, let's assume 2. Okay. Now f of xi is 3, x cubed minus 3x plus 1, x cubed minus 3x plus 1. Then what is f prime of x? Remember, f prime of x is our f of x is x cubed minus 3x plus 1. Therefore, f prime of x is 3x squared minus 3. Okay. So put that in the spreadsheet. 3x squared minus 3. And copy that all the way down here. So I got, from x is 2, I got f prime of x as 9. And applying the formula, xi plus 1 is xi minus f of x over f prime of x. So which is 1.667. And substitute this xi plus 1, you will have this 0.62963 for f of x. Okay. And again, the beauty of Newton's method, the solution will converge towards the real solution. From the initial condition of x, it will converge towards the real solution, which is 1.54 or 1.53209. Okay, 1.53209. Because our f of x here is less than 0.001. So let's see, 1.53. As you observe, yeah, so that is 1.532. And if we check the graph, where is that? We are here, between 1.5 and 1.6. Okay, so how about the other root here, which is near -2? So again, using Newton's method, I assumed an initial x of -3. Okay, same thing as we did here on the left. Okay, so -3, f of x is -17, f prime of x is 24, then xi plus 1 is -2.29. Okay, now you will see that our x, where the f of x, the x wherein f of x is near 0 is around here. So that is -1.8794. Okay, so that's our last root, which is -1.879. Okay, so again, if we will review the graph, okay, our graph, our function x cubed minus 3x plus 1, just this one. Okay. So I'll erase this. So reviewing the roots, we have here 1.5 something, this is 0.347 something, and this is -1.89. Okay, Then we got this 0.347 from Moss. We got this from Newton's method. And this one. Okay, so that's all for the method of successive substitution.